Hello and welcome to episode 95, part 1 for May 2020. This month we're going out live via Zoom and YouTube for our very first live recording of a main episode, hopefully to help alleviate some of the stress and anxiety about being cooped up indoors as a virus tries to sweep you away. We had a bacteria almost wipe us out during our first Martian invasion over 100 years ago, so let's see how you like it. Anyway, we've got a show filled with astronomy goodness, ridiculously clear skies to enjoy with planets returning to our skies, a new comet, and a dazzling array of summer sky, deep sky objects popping up over the horizon just waiting to be observed or imaged. So sit back and enjoy for the next hour as we go through the latest inspiring news from the world of astronomy, some stargazing inspiration for the month of May. Jenny takes a look at the sub-millimeter and far infrared part of the electromagnetic spectrum and why they're so important to professional astronomy, and we'll answer a question about putting satellites in distant orbits. As with our live Q&A show last month, if you feel inclined, drop your astronomy thoughts or comments into Zoom or Twitter at AwesomeAstropod, and we'll read them out as we go along. So let's make this as interactive as we can. So on with the show, and I'm Ralph, your host for this month, and joining me as always are Jen.
Way!
And Paul.
Hello.
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 How are you both doing, guys?
Good, thank you.
Oh, I feel rough.
I see you've got a different background to last time, but still in Australia, Jen.
It is still in Australia. This is the control room of the AAT, the Anglo-Australian telescope.
Whoa, which is where you were when you were doing your research.
Yeah, well, we went for a visit, right?
Yeah.
Up to Siding Springs, and so we got to have a look. And I was in the control room. This is where I was when New Horizons made its closest approach to Pluto.
Oh, we're talking about that later.
Yeah.
So,
and you've dressed down this time, Paul.
I have. I've gone all skater boy.
It would be difficult to dress up from last time, wouldn't it? You were tuxedoed.
Yeah, or Quasimodo is probably more the Esmeralda. The bells.
So let's start up with something that's dividing opinion. And we got quite excited about it. Twitter got quite excited about it, and it feels wrong to get excited about it. But we were enjoying some of the Starlink passes recently this past week, weren't we?
It's the love-hate relationship, isn't it?
Yeah, it is.
I was both kind of amazed by it and horrified by it simultaneously. It was brilliant.
Yeah.
But ironically, given that you are a die-hard observer and sketcher, you were actually imaging it as it went over. So that's taking quite a leap, Paul. Yeah.
It was great. You should have seen me. I was running every Tuesday. I run an online astronomy event for a group. There was about 50 to 100 people come along, and it was that kind of really good one of that kind of chain of about 60 all kind of going over in a long line every kind of 20 seconds or so. Came over midway through, and somebody was I kind of half remembered it. Keep an eye out for it while we're sitting outside looking. And one of the people went, I can see something going over. Is this the set? And everyone sort of leaned back. You see everyone on Zoom sort of leaning back, and then it was brilliant. So like 50 people going, wow, that's amazing. And then me, I'm leaping out of my seat, being my usual, like, that's incredible, that's incredible. Sort of leaping around the garden, just disappearing off camera, going, that's amazing. And then going, actually, it's really awful.
It feels wrong saying that something's awful, that the rest of the world's going, this is brilliant.
Yeah. And the one I got excited about, the one I took some pictures of, was the Falcon 9.
Yes.
It's the first time I've seen a Falcon 9 go over, actually. Because that was just amazing. That was really, really I think the last couple of Falcon 9s that could have gone over the UK were all cloudy where I was, so I never saw them. So it was just really exciting to sort of see the launch live on YouTube, see that rocket take off, and then 20 minutes later, you were like, there it was.
There it is. Yeah.
That's really cool.
Peter Coates has just popped in on the Zoom webinar chat and just put the live launch, and then seeing it fly over 15 minutes later was pretty fantastic. He got loads of workmates involved as well, which is nice.
Yeah, it was very cool. I even got my other half out when she never does astronomy, so she was very excited she even sat out and watched it over several evenings and looked at the stars and things.
Wow.
So,
Yeah, I managed to get my wife out as well to take a look. Not that interested, but I managed to drag her out anyway. But Jen, you've been beaming out onto the airwaves on radio on BBC no less this week.
For some reason, I became like the UK's expert on Starlink for a hot minute. I don't know like what happened, but
the BBC's go-to person.
Yeah, I had to feel, because I've been on their like list of people that they can contact if anything interesting astronomy wise happens for a while, but I haven't had any calls. And it was Radio 5 Live called first, asking could I, do a short interview about Starlink, and I was like, yeah, okay, fine, panicking. But I think it went well. And then the next day I got BBC Radio Wales and then BBC Radio Ulster. Like, well, they were originally going to be almost back to back. It was like I was contacting I think my Alexa's just gone off. I don't know
Turning
why.
on Radio Ulster.
Yeah.
Alexa, has Jenny been to Australia?
Oh, see, that would work if I didn't have headphones in. But yeah, it was going to be BBC Radio Ulster at like past, and then it was going to be BBC Radio Wales at like 22. So I was like coordinating with them both, being like, I have to be off because I have to be on the phone again for someone else in like 10 minutes time. But then the BBC Wales one got delayed, and anyway, it was fine, and it was very strange, and I was famous for about 2 minutes.
Yeah, it was really good as well.
They were very, very good. Although my favourite bit was John was recording them for you.
Yes.
And the Welsh one, he recorded the wrong BBC Wales, because there's also the BBC Wales that's in Welsh, which you weren't on.
I think he did BBC Radio Cymru rather than BBC Radio Wales.
And that was my favourite. So he's like, you're not on yet. There's a lot of Welsh speaking people on. That was my favourite. But actually, were very, very good. Very good. Very good.
Thank you. I liked the BBC 5 Live one the best, I think, because I actually got to talk a little bit about like why do we like Starlink, why don't we like Starlink.
Yeah.
Whereas the other two were very much like, when can we see it? What are we going to see? Job done.
Better class of radio presenters on national. So, following on from our live Q&A show, what was it, a couple of weeks ago, when we had Gav on, because it was just so fortuitous that we were recording that show at the point 50 years ago that Apollo 13 was still making its way back to Earth. There's a kind of doomed spacecraft hoping that they make it back. But there's been all sorts of Apollo 13 stuff going on.
Oh yeah, definitely. Like, I've just been loving my Twitter feed recently. It's just been, coronavirus finally went away for a few days, and it was just kind of dominated by like Apollo 13 stuff, like, hey, they just, passed this milestone, and it's like, they're gonna come into land, and it's like the parachute is being deployed, and it's like blah blah blah. And, yeah,
I enjoyed I couldn't take part because I was doing something else, but there were people who lined up the film with the launch moment.
Oh, really?
So they did it like a live launch, and they timed watching the film. So it was like a mass watching of people, and they were all tweeting about it. John Chinner, I don't know if he's with us tonight. He did it, and they timed the launch point in the movie to go along with the launch moment in reality.
Oh,
is that kind of like the space equivalent of when you're tripping balls on acid and you put Dark Side of the Moon to the Wizard of Oz?
I think so. But it was.
So, John, if you were tripping balls, let us know.
But I thought it was like one of those brilliant, geeky, nerdy, marvelous things that just was just such a great idea. And I wish I could have taken part, but I was busy. But I was kind of keeping on people like tweeting about it and saying like, oh, they got to this point, this point. It was brilliant. But it's really interesting how Apollo 13 does still capture people's imaginations, doesn't it?
Yeah.
It's nothing like a bit of drama and disaster to kind of focus the mind.
Quite right. I mean, that was the whole thing, wasn't it? That even Apollo 12, not many people were watching that because they'd been to the moon and people had lost interest. By Apollo 13, I Love Lucy replays were, repeats were on TV rather than playing these astronauts that were on the way to the moon. People's attention span is just crazy, isn't it? And we're going to have all that to look forward to again in 2024 or whenever it is that they go back to the moon.
Really? 2020? It's not going to happen.
2026, isn't it? It's going to be 2026.
7, 8,
Mm-mm.
maybe 30.
Oh, it's all going James Webb.
It's all going James Webb. And I mean, to be fair to NASA, they've definitely got a bit of delay built in now, haven't we?
Well, yes, everything's going to slip to the right.
So there is no way that deadline's going to be met now. It's all moved to the right, isn't it?
Yeah, it's going to have to be. Yeah. Okay, so just move on to an email before we get into the main show proper. And I've just got one that I want to read out from our good friend Clem Unger in Australia, who emailed about our live show. And I guess it applies to this one as well. Great show. I enjoyed it despite the ungodly hour in Oz. Maybe next time it will work out to join. Stay safe, Clem. And we had a bit of a discussion about this because, we realised that, with time zone, it's going to be really difficult. Somebody's not going to work out. But ultimately, we decided those in the Southern Hemisphere are in a vast minority, and our own personal comfort is the most important thing in this. So we're sticking with 8 o'clock. So sorry about that, Clem. I hope you're here. I hope some of our Australian listeners are still listening to this, or our New Zealand listeners. I think there's 3 of those. If we do more live shows in the future, we will probably stick to this kind of time slot because it just works around the UK but so much better. Okay, so on to the show proper with some of the latest astronomy research. Goodbye to Hubble. Oh no. Something quite interesting about asteroids and a few more taunts towards Pluto. So Jen, do you want to kick us off with the news?
Yeah, because when this officially gets released, right, we're going to be in May. And it is tradition for me in May to review the wonderful April Fool's papers that were released at the start of last month, because they're always released on the 1st of April, right? Yeah. So we always miss them for the April shows. And there were some absolutely stellar ones, pun perfectly intended then. So the first one is from researchers at Oxford, including our very good friend Chris Lintott. He's on this paper. This is defining the really habitable zone, and it discusses the problem that although we know a lot about planets in the habitable zones of their stars, where the temperatures are right, we think, for liquid water on the surface of these planets, are any of them actually worth inhabiting? Right, and so they define the really habitable zone as the region around a star where acceptable gin and tonics are likely to be abundant, which I very much agree with. I agree with this criteria.
That is very Chris Lintott.
So I've got some quotes from the paper because they are, they're just sublime. So we've got, in common with much of the work in the field, we rely throughout on assumptions which are difficult, if not impossible, to test, which is very, very true of astronomy. And we suggest that planets in the really habitable zone be early targets for the JWST, because by the time that thing finally launches, we're all going to need a drink. And of course, no paper's complete without an acronym, right? And this one has MAGIC, which is the minimum acceptable gin and tonic. And in true astronomy form, it's, minimum acceptable gin, fine, and then it's the ick from tonic.
I can accept that one. I can accept that. I'll go with that one.
Yeah.
So
as long as it's tenuous.
Yeah. And then the next one I want to talk about is some researchers at Cambridge proposed searching for space vampires with TESS, but it's TE subscript V. SS, standing for the Transiting Exo-Vampire Survey Satellite. And this paper opens with, it is a truth universally acknowledged that a single human in possession of a good space telescope must be in search of a space vampire. And in this paper, they say that they want to look for vampires which are trapped in the gravitational pull of M dwarf stars. And they provide 2 different model light curves for these vampires, one for those in bat form and then one for them in human form. Across the pond, Mike at Caltech says, making it rain, how giving me telescope time can reduce drought. And he shows how recent observing runs he went on resulted in a 200% increase in rainfall than typical for the area. And so telescope committee should give him and his team an unlimited amount of telescope time for telescopes in drought-stricken areas.
It has to be worth a go.
Yeah, I don't think that one's even a joke. That's true.
This is the thing. I think it's thinly veiled as a joke, and it's really the astronomer going, please, for the love of God, give me telescope time. My last one then is Douglas and Ali from the University of British Columbia in Canada, and they give us a new logic for finding life, and they argue this is going to allow us to become a lot more successful in finding life elsewhere. And the logic goes, all elephants are grey, mice are grey, therefore mice are elephants. All right, this is how the logic works. So then for the exoplanets, it goes, the Earth has life, some other places are like the Earth, and therefore these other places have life. And although they're kind of trying to make a jokey argument, I feel like that's actually not too far from the sort of logic that we do actually use, because we say like the Earth has water, the Earth has life, therefore where there is water, there must be life.
I have a feeling they're trolling the exoplanet community with that comment.
Yeah, a little bit. Yeah. But yeah, so those were the ones. There were more. There was one about dark matter, which I didn't really understand. But
nobody does.
No. But yeah, so if you want to go and have a look at them, yeah, you just type in things like space vampires and the really habitable zone, and I'm sure that the papers will come up.
So presumably they just dump these on Archive, do they?
They just get dumped on Archive.
Yeah.
Yeah, they obviously not published in like a proper journal,
but Nature.
Yeah, there's like a special, sort of, I guess. I mean, I've never done one. Maybe I should do one next year. But I guess they just kind of flag it to Archive and be like, this is an April Fool's paper, because when you like submit a paper, you have to sort of say like, oh, which categories it belongs to. Is it galaxies, star formation, whatever. And some of them had like, space, telescopes, garlic as like the criteria for the different papers. Yeah. Anyway, proper news. And my first bit is just casually mentioning that it's been 30 years since HST launched. Yay! Yes,
yeah.
Yeah, whole 30 years, 24th of April.
Yeah.
So it was 3 days ago as we're recording. Here's a little fact to make you Martians feel old. I haven't actually known a day without Hubble staring at the skies.
Yeah, thanks for that, John.
Good for that. I need a drink. I was at secondary school when that thing launched. I remember watching it.
Yeah.
I was but a twinkle in my father's eye. Yeah, so 3 decades, right? Hubble has completely changed our understanding of the universe, right? It's really not an exaggeration to say that. It's discovered galaxies that existed 400 million years after the Big Bang. It's explored the atmospheres of exoplanets. It's unraveled the solar system. It's discovered black holes. And it's been part of 15,000 research papers, which I think is pretty extraordinary.
That's got to be a record, hasn't it?
Well, it's got to be, surely. 15,000 papers, So anyway, happy birthday, HST.
And just two comments from the chat on your ageism. We've got Mr. Morgan says, time to throw her off for that comment.
What does it mean? Does it mean off a cliff? Off
horizon? Astronomy according to Mountain Madman says, nice work, Jen. Look at them squirm.
I know, right? It's great. I mean, you guys always try and make me pronounce things that I can't pronounce. And so I feel like this is like my getting back at you. But yeah, before we move on from Hubble, a little bit of disappointment, really. It's Comet Atlas.
Oh, I'm sorry. No, I've just got to just quick interrupt, because there's another great comment just come in.
Yep.
First time watching live. Always thought Paul was the younger.
Actually, that's a bad comment, because that suggests that he thinks now you look older than me, which is bad, because I'm older than you.
You are. You are.
But Paul's got kids.
Yeah.
Kids aging.
They do. I'm actually only 24.
And Damien's somewhere in the wings in the background,
Methuselah.
and he always makes us all feel younger.
Damien Methuselah.
Yeah.
Painting in the attic.
He remembers. He doesn't remember just the HST being launched. He remembers Herschel building his first telescope.
In fact, he helped.
Yes. Anyway, sorry, Jen.
No, it's all right. Don't worry about it. Yeah, I'm going to talk about something sad anyway, so we may as well delay it for as long as possible because it's Comet Atlas.
Oh yeah.
I know, right? You know, the comet of a generation is what it was hoped to be. Naked eye visibility. It's not the case, is it? Hubble's recently took a few images of it, and the nucleus has clearly broken up into several pieces. And this is obviously terrible for amateur astronomers, but not necessarily for the professionals, because although everyone is disappointed about the breakage, it actually gives astronomers a great chance to study why these comets break up and what they're made of. And so, you know, we can still learn a lot of stuff about it. So, you know, silver linings. And
it looked really cool.
Yeah.
It did. It looked really good as it was breaking up the images that people took. And that's a really good thing to see as well, that there are so many more amateur astronomers that have got the kit and the sensors now to be able to take, just from people's back gardens, really good images of these things that was pretty much impossible unless you got professional grade equipment 10 years ago. And we've got Swift as well as a potential replacement.
We have.
Comet Swift.
Go on, someone say it. Someone say it. Captain Comets. Go on, say it.
No, what?
The Captain Comets comment. Someone's going to say it.
Don't know it.
Nope.
Nope.
Oh, come on.
Nope.
Comets are like cats.
Oh, yeah.
Push my glasses up my nose. They have tails and they do what they like.
What my cat's done today? Nothing. She has literally sat in the middle of my bed and slept for about 12 hours.
Well, that's good, because if she starts sublimating, she'll break up.
I'll try and get a tablet to stop her doing that. But
Damien's saying that's a normal day for a cat, though.
Yeah, no, yeah, I mean, it is.
And he's had a long experience of what cats do. He remembers when they were worshipped in Egypt.
Yeah, but that's it. Yeah. They're just bitter now. They just lie there going, I remember when I was a god. Now look at me.
Yeah, Damien remembers that. He was the original pharaoh.
Yeah.
Oh, I don't know. Is he cool enough to be a pharaoh? Maybe the pharaoh's cat tamer. All right, anyway, I'm going to finish my news before this recording of an hour turns into 2.
Yeah.
But my last story is about another disappearing act, and this is that Fomalhaut B is no more.
What?
Yes.
We've lost a planet. So Fomalhaut is a very bright nearby star. It's only 25 light years away. So when we found a planet around it in 2004, everyone was super, super excited. You know, to have a planet that we can actually image. You know, we can actually physically take pictures of it was very, very exciting. And especially because this was a young planet, because Fomalhaut has a big debris disk around it. So, you know, we were seeing what we thought we were seeing anyway, the very early sort of stages of planet formation. But follow-up images have found that, the planet has literally just disappeared. Over 10 years, images from, guess where? Hubble. I see I have a bit of a theme for my news this month. But images from Hubble showed that Fomalhaut B, it kind of just slowly fades in brightness, and then just kind of like got more and more diffuse and kind of grew in extent. And so now they think that it's probably, guess what, dust.
well, whoever it was that mentioned that on the chat room and in the chat group just a moment ago was absolutely right. Well done.
Yeah. That is Morgan says it'll be dust, and you are right, Morgan. They think it is a cloud of dust, probably from the collision of 2 planetesimals.
So almost an exoplanet. Well,
almost an exoplanet. Not quite though.
So just my naughty question: how many exoplanets we so far classified aren't?
See, now I asked this very question because we talked about this. We had a group meeting last week and we talked about it, and I asked that question. I was like, so like how many exoplanets are actually just dust? And the exoplanet expert is confident that all the exoplanets that we have found are going to be exoplanets. It's because this was a very unusual system, because it's actually like a system that we look at, we can visibly see the pictures, so the planet wasn't detected by like the transit method or the radial velocity or anything. Like all of those are safe. It's only going to be the systems where we're kind of looking at pictures of them that maybe we're not looking at a picture of the right thing. However, the difference here is that because Fomalhaut is such a young star and it's got this great big debris disk around it, we would expect maybe to have more of these artifacts than we would around, say, like a normal, sort of more of a long sort of main sequence life star. So it should be fine. This should be a fluke. Because seeing something like this is extremely rare.
Yeah, it was a fantastic image though when we first saw it, and it was quite groundbreaking as well.
Yeah.
So bring us back into the solar system, Paul. What have you got for us?
Right. Okay. First up for me, it's asteroids. Love an asteroid. They're one of the great overlooked components of the solar system. Everyone obsesses about Mars and Saturn. Curiosity this, Cassini that. Oh, aren't I so beautiful, says Saturn. Look at my sexy dry riverbed, says Mars. Anyway, asteroids. The great unloved detritus that seem to be viewed as nothing more than the next resource for late-stage capitalism to exploit. Once the investors they're trick enough fools to part with their cash. Well, as ever, when we look more closely, secrets and surprises are revealed. And in this case, it's about Centaurs. So those are the asteroids that sit amongst the large outer planets, and they cross the orbit. So they're the sort of definition of them is they kind of orbit around Jupiter, Saturn, Neptune, and Uranus, and they must cross at least one of those orbits. They usually cross more than one, and they're an oddity because they've always been a bit of an oddity because they have really weird orbits, but they seem to be quite stable. So they've always been a bit of a curiosity, and well. It turns out a team led by Fatih Noumeni at the Observatory La Côte d'Azur in France, joined by various institutes in Brazil, including the University Estatal Paulista.
Nice one.
I hope that was right. I've had a look at the strange but stable orbits these bodies have and modelled them a lot. And when I say a lot, they made 10,000 clones.
Wow.
Of 21 of these Centaurs. So they did 10,000 copies of each one and did a lot of simulation to see where they might have come from. And they've come to the conclusion that Centaurs are a population of stolen asteroids. These aren't bodies from our solar system.
Where?
From the inner solar system?
From another solar system.
Whoa!
Yeah. These aren't solar system objects. You know how we got excited about everyone on YouTube doesn't know how we
Yeah, Paul can love everybody now, not just us.
Please take some of the love.
And Borisov, the two kind of the
asteroid and the comet,
exocomets that have passed through. Everyone got excited about them, and then we've been thinking, how can we have a mission to go and kind of have a look at these? Well, it turns out there's a whole population of them sitting in stable orbits just by the gas giants. Ready for the looking at. So it's more exciting.
So cool.
If you remember, this is the target of a mid-decade NASA mission as well. We talked about this a few months ago.
Yeah.
So that's exciting. We may be about to explore fragments from other star systems.
So how confident are we? Is this just a hypothesis?
No, it's a hypothesis, but they're very confident based on this modelling that basically the only way these things can be where they are, in the orbits that they are, they've done a lot of modelling, is that they've been ripped out of other systems.
Taking a look at the mineralogy of those would be exciting, wouldn't it?
Yeah, exactly. And what's interesting is they're potentially, the way this would happen, they're potentially fragments from the sun's siblings, picked up in the kind of early days inside the open cluster that the sun was sitting in with its other, brothers and sisters as it formed. So you imagine the early solar system forming in that open cluster. There it is, and much close proximity to other stars. They move around and flung out. And so these have been potentially ripped out of these other systems. So
I love it.
They have a gold mine of information and data potentially. We have a whole population of bits of rock from other systems potentially within reach. If you want to follow that up, that's in the monthly notices of the RAS this month, published actually just 3 days ago. So that's hot off the press, that one.
Cool.
Okay. Look at those
Paul, you're
tiny
being
hands
accused of being a
of
bit
Paul.
trumpy there.
Rahul said, "Look at those tiny hands of Paul."
I tell you what, people are shitting all over you, aren't they, tonight?
Yeah, you put them nearer to the camera and then they'll look bigger.
I'll sit here with my massive hands. You're not the first person. You know, I used to have when I first started teaching many years ago, I had a student. I took a trip to France, and this year 9 girl sat down next to me and said, "Oh, sir, I do feel sorry for your little chipolata fingers."
At least she said fingers.
Like it was like the pity of a 14-year-old about my short, fat fingers. It was like, thanks for that. Thank you.
I have really small ears.
Do your glasses fall off regularly?
No, but it's just when people see me, like they'll be my friend for a few months, and then one day we'll just be having a conversation, and they'll just stop and they'll like lean in and they'll go, "Your ears are really small," and I'm like, "I have been told."
And then they can no longer be your friend.
Then that's it. That's why I don't have many friends.
Right.
Small ears.
Okay. Anyway, enough with the small body part,
which I'm keeping discreetly covered with my hair right now.
Okay, next up, Pluto, the not planet, that is causing debate around its origin. Namely, did it have a hot start or a cold start? This is all based on the data gathered by New Horizons. We were going to talk about New Horizons. Remember that? 5 years ago now, believe it or not.
New Horizons was 5 years ago.
5 years, I know.
I think Jenny was in Australia then.
5.
That's when I peaked. I peaked 5 years ago. It's all been downhill since
5 years. I had more hair and like bits of me worked. My knees didn't ache then.
Wow.
Anyway, the data is rich, the data is interesting, and the analysis is revealing all sorts of interesting things. In this case, the evidence seems to be coming down on the side of a hot start to the little planet that isn't early years. Both scenarios point to a subsurface ocean of which we now have, we sort of have evidence, but this is a question about, was it a cold start? So is it a sort of icy ocean that happened in a sort of gradual accumulation of stuff? So did it get over it, Matthew Hodgson? He's saying not planet, dead to me, Paul. Anyway, so the gradual accumulation of this stuff kind of building up, and Pluto grew slowly, and so there was a sort of subsurface ocean that was cold and took a while to form and things like that. That's that. So if we saw that, we would see compression features on the surface. So if it was made up of lots of little bits coming in, you would see it slowly. It would be just constantly compressed and compressed as the gravity built up. It would pull in the next layer of stuff, and you would see these sort of crushing compression features on the surface. If it had a hot start, as in it formed very, very quickly, and therefore had this sort of warmer liquid ocean underneath, and it kind of kept its internal heat and didn't leak it out to space so quickly. What would happen is it would cool down from the surface down, and of course the ice would expand, and you would get these sort of expansional features. So of course, as the ice expands, you would get these features as the kind of surface expands outwards in various sort of forms. And that would be the clue that we had a hot Pluto start, and that there was a sort of deep, liquid, warmer ocean at work. And well, they've been searching, a team from the US universities that were involved in the New Horizons mission. They were presenting at the 51st Planetary and Lunar Conference, remotely and virtually, I might add, as is the fashion these days. And they presented this evidence around the Sputnik Planitia that it's full of expansional features. And that Pluto's actually demonstrates, just by looking at the expansional features on the surface, that it was a hot Pluto to start with, and therefore had a sort of deep, liquid, warm ocean at the beginning and formed really quickly, which tells us all sorts of stuff about the Kuiper Belt and the outer parts of the solar system. So exciting stuff. If you want to follow that up, it's the plausibility of an ocean on Pluto shortly after accretion.
Lovely. Thank you very much, Paul. And for the main news story this month that we want to discuss, we've got something that highlights something that we mention quite often. That's the value of going back over old data, as astronomers have just done with old Kepler Space Telescope data. And they've only gone and blooming found the most Earth-sized, potentially habitable exoplanet. I mean, this is...
It's an Earth 2.0 alert.
Well, I mean, on the face of things, it's 1.06% larger than Earth, which I think, given that this is the transit method, means that it has to be by mass.
Volume.
Volume.
Because
Yes.
as it goes across, you're
Or-
seeing the size.
Or it's really, really flat. It's actually like plate kind of.
Or
It's a big disc.
it's a space vampire who's curled up in a ball.
Or it's just a projection like the moon is.
Yeah, exactly. Just mirrors. There's
All the
nothing.
way
There's
down.
nothing. There's nothing beyond the orbit of Mars. It's all mirrors.
We know from a telescope retailer that there is somebody that will happily come and sit in a showroom and talk to them for half an hour about how the moon is just a hologram projection.
Mm.
Anyway, back to the news story.
Yeah, sorry.
This is really good. This is really exciting because what I liked also is this was quietly announced. It wasn't the usual we found Earth 2.0 quick.
Yeah.
It wasn't anything like that. It just they found some old data. Went, look at that.
It's quite clear that all of NASA's press team are furloughed, aren't they?
Yeah.
Because we're getting proper science rather than just extravagant news stories.
Exactly. It just quietly slipped out, and it was really exciting.
Yeah.
It's only 300 light years away.
Yeah,
It's not that-
when I was reading about this, I think it also highlights the value of getting people to still look at data, because this was found in data that had sort of been checked by the sort of AI and the automated processes that they have, and it hadn't been classified as a planet. And so people went back over the sort of things that had been checked out just to double check them, and here we are.
Yeah,
And
Well,
this has cropped up
2.0.
twice. The importance of having humans checking it, because just in the last show, well, the last Q&A show a couple of weeks ago, Chris Lintott was talking about the AI algorithms looking at supernova and ignoring one because it was too bright.
Yeah.
It considered it to be too bright and just ignored it. But when people went over it again, they realised it was. And it just makes you wonder about so many things now that are being left to AI to look at. How much are we missing? And something like this just writes it large. It's Earth.
I think we're going to get a lot more of this just from the sheer volume of data that there is anyway.
Yeah.
Regardless of AI, I mean, Kepler, the amount of data that Kepler took in its mission is just vast.
Yeah.
And every mission is providing more and more data that's going to take years to go through. I mean, it's like that New Horizons data we were just talking about. That was 5 years ago, and we're only talking about stuff that was just taken from images and the surface details and things like radar paths and things. That it's been around for 5 years, and it's taken this long to get to even just sort of topography stuff. So we're going to get loads more of this. This is really exciting for this.
Yeah. And it's interesting as well that I think it was Jen that had a news story a month or so ago about how planets around red dwarf stars actually might be more habitable than we first thought. And of course, this is an exoplanet around around a red dwarf star, so its habitability zone is much closer in to something that we would expect to flare more, be more radiation unstable. But that doesn't necessarily mean, based on some more research that's coming out now, that it's any less habitable.
Yeah, that research from before was it was a team of astronomers and biologists. They sort of teamed up, and they did so the astronomers sort of modeled the amount of UV flux that you would expect to get at the surface of Proxima during one of these flares, and then and what sort of atmosphere you would need to protect the surface of the planet from this UV radiation. UV radiation is really damaging because it literally breaks apart DNA and stuff. It completely destroys life. We use it to sterilize the air and the water here on Earth, so it's pretty bad. But so the astronomers found that you didn't have to have oxygen in your atmosphere to have protection from UV. You could just have a combination of nitrogen and carbon dioxide, which is great because that's the first time that's ever been shown. And then the biologists were like, hey, what if we don't have an atmosphere? Could life survive without an atmosphere? And their answer was yes, that you get a small proportion of the bacteria survives. And then it's a question of how long do the bacteria need to sort of grow back up into a big colony. before then, when the next flare comes in, they can sort of survive, and there's just this cycle of destruction, but never total destruction. So yeah, maybe not big old aliens, but maybe some bacteria. So yeah, it's interesting.
Who knows? Yeah. So I think Damien's somewhere there in the background. I don't know if he can speak out, but I did ask him just before we went live if there was any possibility that he could put the stinger music between segments in. And if you are there, Damien, what did you say?
Methuselah said no.
It was a plain no. So I don't know if we can bring in anyone else that's on this show to do as a little stinger in the middle. Can we do that, John? Does anybody want to? Because we're going to move between segments
ditty.
now. Can someone give us a?
Is this going to be the awesome astronomy choir?
Yes. We've all seen it via Zoom. They'll do.
Who's in our little box here? They might. Someone might do it.
Does anybody want to do it? Give us a shout out. Come on, does somebody want to do it? Give us a wah 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 wah.
The answer is no.
No
one wants
to
do it.
Quiet. So they spent the last half hour insulting me, and now you asked them to do something, and they've all gone off for a piss and a beer or something.
Compliment me. Okay, we'll move on then. So we'll turn our attention to the practical side of the show with our monthly sky guide, and this month we're returning to the promise of lots of planets on display, a new comet and a couple of meteor showers, but we'll start further afield with the Great Bear Ursa Major. Jan.
Ursa Major, biggest northern constellation, third largest overall. It's beaten by Hydra and Virgo, but still it covers almost, get this, 1,300 square degrees of sky.
What?
Yeah, it's massive. Right, I was looking this up and I was like, no, I don't believe this. But yeah, almost 1,300 square degrees of sky. And I reckon that although people probably don't necessarily know that they know where Ursa Major is, if people aren't really into their astronomy, they do, because they know that asterism of the Big Dipper, the Plough, or in my very Welsh accent, the saucepan. So the saucepan. Yeah. It's also it has a long history, right? It goes back to Homer talks about it, Ptolemy talks about it. It's even in the Bible, of all places. So science, religion, hand in hand.
So yeah, Ursa Major, the greater she-bear is actually the official translation. How about that? The greater she-bear. It's probably one of the oldest constellations, as Jenny said, in human history. Its evidence actually goes even further back than the Bible, that it's known in prehistory that this was referred to as the bear, or the collection of stars certainly is kind of recognised a long way back. If you want the Greco-Roman story, okay, it's the nymph Callisto, who is lusted over by Jupiter, the dirty cad, and the big J's missus, Juno, discovers that there's a son, Arcus, who's born is born of this little liaison. So she turns Callisto into a bear.
I mean, that's one way to stop it happening again, right?
Arcus, right? Arcus, the son, comes across the bear, almost kills his own mother.
I feel like this is like Brave or something. This is
exactly what I was thinking. I was like, I see where Disney were going now.
Yeah.
So to avert the tragedy, Jupiter, the dirty cad, turns Arcus into a bear, and mother and son live on as Ursa Major and Minor in the sky.
Aww.
Isn't that lovely?
Isn't that lovely? Other traditions see the group as sages, the 7 sages in Hinduism, or as a group of heavenly objects, as they do in China. Location is probably the least difficult one. At the moment, look straight up at zenith. Yeah. It is there. You'll not fail to see the familiar saucepan shape that forms the arse and tail of Jupiter's ursine crumpet. It will, of course, move around the sky, though through the year, of course, orbiting Polaris through the night, in fact. And this is where it gets its other ancient name from, the Helaik, which means the turning.
Thank you very much for that.
I need a pipe now.
Okay, so I'm going to cover a couple of deep sky picks now that are in Ursa Major, and I'm going to go with a trio of sensational galaxies to observe in small to medium-sized scopes. So anybody should be able to pick these out. Actually, two of them can be viewed together, while the third is like looking at our own Milky Way galaxy from above. So for the dedicated amateur astronomers, you'll already know what I've picked. And the first one up is Messier 101, the Pinwheel galaxy. And although it's listed as magnitude 7.9, its light is spread out across the galaxy, giving it a kind of general low surface brightness. So it really doesn't stand out quite so well, meaning that you may need to really lower the magnification. That's a top tip with these kind of low surface brightness galaxies. To lower the magnification, don't keep trying to crank it up, or just be patient and employ averted vision, unless you use a 6-inch scope or larger. But it's well worth the effort, because this is what's called a grand design spiral galaxy, meaning that it has a well-defined structure and the spiral arms are apparent in telescope views. It has also had 4 times more occurrences of supernova than the average over the last 100 years, and 2 in the last 6 years. So it's one to keep an eye on, because there's clearly something going on there that's creating more supernovae than you'd expect. To see 101, find the 2 handled stars, Alkaid and Mizar, in Ursa Major the Plough. M101 forms the apex of an equilateral triangle above these 2 stars. Then next up is the twin galaxies of Messier 81, Bode's galaxy, and Messier 82, the Cigar galaxy. To find this pair, move up the handle of the Big Dipper to the star that dips down to begin the bowl, Fad or Fector. Now draw a line from that star to the end star back out of the bowl, Dubhe. Continue that line for the same distance and you get a spiral galaxy and an edge-on spiral galaxy, both within the same field of view of a low-power eyepiece. Now, gravitational interactions between the 2 galaxies set off rapid star formation in M82, leading it to often being referred to as a starburst galaxy. The reason that it stands out, more than its companion, despite being more slender from our vantage point. And thank you so much. If anyone's downloading this in a couple of days' time, they won't get the benefit of Paul acting this out. Paul doing charades.
I'm doing interpretive dance of M81 and M82 colliding.
The astronomical Marcel Marceau.
Right there.
There we go, look.
But nevertheless, these should both be very easy to spot after looking at the dimmer, but no less spectacular Pinwheel galaxy.
Don't forget, there's one of the great planetary nebulas as well in the middle of the Bear, just behind the star Merak, at the bottom of the 2 pointers. If you work along the base of the source from Merak, you'll come quite easily to M97. It's really difficult to miss. It's the Owl Nebula. And larger scopes, you'll pick out the eyes, the owl face, where you'll see why it's called the owl. And right near it is M108, a spiral galaxy that's in a nice wide field lens. You can see the same view as the owl, which is a really cool view.
You're making me feel really sad there, Paul, because I had a go at that from central London, central Cydonia, just last week under perfect sky conditions, or as perfect as they can be in London, Cydonia, and not even a whiff of it.
Oh.
It's bloody easy in my part of Cydonia, Wiltshire.
You've got the dark half of the bunker.
I got the dark half of the garden.
Okay, so moving on to the solar system. Yeah.
Venus. I mean, pretty spectacular right now. It's going to continue blazing gloriously in the evening sky for quite a while. I'm not even going to bother telling you where to look. Just literally have a look, and it's the brightest thing in the sky. I mean, yeah, you can't miss it. Mars is technically visible in the southeastern sky before dawn, but extremely low on the horizon. So it's probably not worth going for in terms of imaging and stuff like that. But possibly worth a gander if you've got a clear horizon. And you'll also have Jupiter and Saturn as well at the same time. They'll just be slightly more sort of southerly. On the morning of the 12th, the Moon and Jupiter will be about 2 degrees apart. And then on the morning of the 13th, you'll have the Moon, Saturn, and Jupiter making like a small arc in the sky in the morning. And then to the east of those lot will be Mars. So, I mean, if you're trying to get people into astronomy, you can try shouting at them over to the fence and say, hey, check that out. Obviously, don't go near them. Poke them with your telescope if they get too close.
And as it's about sort of 4 o'clock in the morning, they'll love you for it.
Yeah.
Yeah.
And another reason why a refractor is better than a Maxitov, because they're long enough to poke someone that's trying to get too close to you under social distancing.
But that's it in terms of planets, really. It's not a lot going on, is there? I mean,
but nice to have a couple more at least to look for in the gloom, because it's been quite barren, hasn't it? Apart from Venus that's been beaming away, there's been nothing else, and now it's starting to get.
It'll start to get better. Better.
Yeah, it's waiting for that autumn, isn't it? When Jupiter ain't going to be back in the sky, the sort of dark evening skies. Can't wait for that.
Yeah.
So for the meteor showers this month, we have 2 fair to middling displays for Northern Hemisphere dwellers, one of which will be visible from the Southern Hemisphere too. Firstly, we have the more impressive of the 2 showers on offer this month, the Itza Lyrids, which runs from the 19th of April to the 28th of May each year, peaking on the 6th of May. But peak tends to be more spread out than most other meteor showers, so it lasts for a good few days either side of the 6th of May. So grab any clear night you can around this time. Like the Orionids, the Itza Lyrids are caused by the Earth passing through the debris left from Halley's Comet as it makes its regular 75-year orbit around the Sun. This shower has a rate of about 1 per minute, and many of them are usually quite bright. However, this year, we do have a full moon all night trying to ruin the party. That said, Northern Hemisphere observers should be patient and face the constellation of Aquarius in the east after sunset. The radiant will be a hand's width above Mars and Neptune after midnight. In the Southern Hemisphere, the radiant will appear a hand's width to the left of bright orange Mars in the east after midnight. I'm saying it's orange. It looks orange to me. It might be red. I don't know. I'm colorblind. So you people with decent vision can correct me on that. Is Mars orange or red?
It's sort of like a pale, peachy, reddy.
Orange. Yeah. Orange.
Yeah.
Mars is just the most disappointing thing in the sky.
Yeah.
Frankly. Mars. Everyone gets excited about looking at Mars in telescopes, and I never see it.
Oh, come on. No. When you've got a nice opposition. Oh, Mars is great.
How can you two see it anyway?
Oh, yeah, let's say we just have to look down at our feet. I mean,
you get the best view of all.
Yeah, that's why I can't understand you saying it's not a great sight. It's fantastic for us, Paul. You can peer right into the craters. Anyway, the second and less impressive shower this month is the Itza Lyrids, which runs from the 3rd to the 14th of May, peaking on the 8th of May. This shower is far less impressive with a rate of just 3 per hour under ideal conditions, but they have been known to be quite eye-catching. These meteors are the debris left behind long-period comet C1983 H1 Iras-Araki-Alcock. As it takes 970 years to complete an orbit, it doesn't get frequent chances to replenish the debris it leaves in Earth's way, and hence the low meteor rate. Fortunately, in the Northern Hemisphere, the radiant in Lyra is very high up and away from the gloom of the horizon, so lie back on a sun lounger as soon as it's dark and try the hour from 10:30 to 11:30 before the moon rises.
We've had a couple of comments come through.
Oh.
Ooh.
All right, here we go. Jen's pronunciation time.
Mm-hmm.
Raphael, maybe? Raphael de Palma?
Yep.
I'm going for. Says, I've tried to put some people into astronomy and showing them Venus, and they were sure it was a satellite. Yeah,
oh, really?
I've had that before. People just don't believe you that it's not something man-made because it's just so bright, and particularly at the minute, it is astonishingly bright. So yeah, I can believe that. Just poke them with your telescope until they believe you. Yeah.
Or bleed.
But don't put the telescope on it and let them look, because then they'll just try and convince you it's the moon because of its crescent shape.
Oh, that's interesting. Has that actually happened?
I would imagine it would do. If you showed a newbie Venus through a telescope, they'd just say, well, it's the moon, a long way away.
Unless the moon was also up.
Yes.
I get that with kids in the sun. When I show kids the sun, they just go, it's the moon.
Really?
Even if...
Yeah. When you get goggles on or through a solar scope, they just go, it's the moon. It's like, no, it's the sun. It's just filtered. It's the sun. You idiot. Morons, all of them. Right, the moon phases. This month, first quarter is on the 1st, full on the 7th, last quarter on the 14th, and new on the 22nd, returning to first quarter on the 30th. So all that remains is to wish you clear skies, and happy hunting.
hunting. And
we have had another comment from Alex Bell.
Oh, yes. Go on.
Is it true that the Alcor Mizar double star was used as a sight test for Roman centurions?
Who knows? It said it was, and also for Arabian horsemen. But who knows? Because it's so easy to spot. I don't know. Unless their eyes were so bad in those days that it was or unless the stars were closer together. Maybe I don't know.
The Pleiades were supposed to be as well. That's another one.
How many you could see?
Supposed to you're supposed to have to like draw the Pleiades.
I'm not being funny, but I can see like Alcor and Mizar from light polluted Cardiff, right? Like, and it is shocking light pollution where I live. So yeah, their eyesight must have been really bad.
Yeah.
They were.
So, I don't know.
It was poorer in the past. Everything was in black and white for a start.
Oh yeah.
Although actually, I'm saying that I can see them when I've got my glasses on. I haven't looked to see if I can actually see them without my glasses on. I'm thinking about it now, and I'm like, oh, actually, maybe it is a good test.
Hang on a minute. There's something in this sight test.
Yeah, there might actually be. Do you know what? I'm gonna have a go. I'm gonna test and tip my glasses off, see if I can still see them.
Yeah.
When it's not cloudy, which it is for like the next 3 days, because it is absolutely pissing down, right?
We have a volunteer, don't we?
Oh, we do. Yes, John's been working around in the background to get us a volunteer to hum the stinger for us. And the great news is we've got our good friend Raoul van Eindhoven. Hopefully, I'm mangling his name, and he's going to do it in Dutch. So take it away, Raoul.
Okay, there we go.
Fantastic. It sounded a bit English to me. Okay, so now we turn to our regular tour and guide to the electromagnetic spectrum. And this month, we're going to take a look at the submillimeter and far infrared part of the spectrum, GN.
Oh, I'm so excited about this bit this time. Because this is what I do my research in, right? So I've literally like word vomited onto the page, and I'm looking at my notes like in the script, and we're gonna be here for a while.
I'm looking at the notes. If anyone needs a break, just like nip out.
Yeah, you've got
away.
To be honest, you've got time for a poo. Like I'm gonna be here for a while.
You're obsessed with poo at the moment. Every conversation
it is coming out of me.
Every conversation, every day on our Kushner back channel involves you and some sort of scatological event.
You might also live with 3 blokes who are, at times.
So it's their scatological events.
Oh,
do you know what I mean? Anyway, back to the science. No more Poogate.
Yeah, you've got time for a takeaway or anything. It's like, kick back, get a beer.
Or get yourself comfortable.
So what I'm going to do in the section this time is I'm going to talk a little bit about what we can learn about the sky sort of at these wavelengths, but I'm also going to talk a little bit about my research because I thought it might be nice to do it. So in general, far infrared submillimeter, it's anything from about 30 microns through to less than 1 millimeter. So for once in astronomy, the name submillimeter is actually pretty self-explanatory, right? It makes sense for once. So we're still looking at long wavelengths, so it's still reasonably low energy stuff. We're looking at cold things, really, far infrared submillimeter astronomy, things that like minus 170 degrees Celsius or, even colder. The dust that I study is, we're sort of looking at minus 250 degrees Celsius. Really, really very, very cold things. And typically we use far infrared submillimeter astronomy for like galactic studies and extragalactic studies. So extragalactic is things outside of our galaxy, and by galactic I mean stuff outside the solar system. But you can study like the outer planets because they're cooler, so they're emitting light at the right temperature. They're emitting light at the right wavelengths, and you can learn some pretty cool things about like comets and asteroids and stuff. And I got a little bit distracted by then by a comment that we've got in from TNT in BC saying it's not poo, it's dust. But I mean, maybe it is. I don't know. Talk to the toilet, see what the toilet says. Anyway, back to submillimeter astronomy. So a great example of when we managed to learn a little bit about the solar system was with Herschel Space Observatory, and it determined the origin of water in the upper atmosphere of Jupiter actually comes from comet impacts. It particularly looked at comet Shoemaker-Levy, and the impact sites of that comet coincided with water vapor in the upper atmosphere of Jupiter. So that's pretty cool. The Herschel Space Observatory also found water vapor on Ceres, which was pretty unexpected because you don't actually, typically expect to find water on asteroids. And it kind of led to the definition between comets and asteroids to become more and more blurred. But far infrared submillimeter astronomy really comes into its own with the study of like gas and dust on galactic and extragalactic scales. That's really where its bread and butter is. And there's lots of spectral lines. I've got to I am getting so distracted by all the comments that are coming in. We've got Blake Furman saying, "Are you sure it's dust, Jen? It could be planets." I mean, this is true, but I hope it isn't, because otherwise all my research is definitely down the place where all the other dust is going, apparently, in my house. Anyway, far infrared submillimeter astronomy. Morgan says, "Close encounter of the turd kind." Which is very, very true. But I'm going to have to minimize this chat. Otherwise, I'm never going to get through this segment. And we are literally going to be here all evening. And I'm going to read out the rest of the comments at the end. So keep them coming. Anyway, back to far infrared submillimeter astronomy. It's all about studying gas and dust, really, galactic and extragalactic scales. There's lots of different spectral lines from different molecules in the far infrared submillimeter, particularly for carbon and oxygen. And particularly as you go back through the history of the universe, you can detect these spectral lines out to like really, really high redshifts. So it helps us to find like some of the earliest galaxies. There's lots of spectral lines for carbon and oxygen. So this means that we can figure out what the gas in galaxies is made of. And it allows us to trace how much of it there is. And that's really important because it helps us figure out like where a galaxy is on its evolutionary path. And it helps us find, evidence of past mergers, things like that. And then we've got giant molecular clouds, the birthplace of stars. If we can work out how much gas there is, we can predict how many stars will form, what mass they might have, and that helps us learn about how stars form in general. But really, the far infrared submillimeter is where stars themselves actually fade away and where dust, my favorite thing, begins to glow. And it is this part of the spectrum that allows us to see the universe in Jesus Christ, Paul, I was on a roll then.
Is that a Cabbage Patch doll that Paul's just put in his picture frame?
So anyone who's not listening to this, they're listening to the recording afterwards. Paul turned his video off and he's now turned it back on, and he's replaced himself with a Cabbage Patch doll wearing his hoodie, just staring blankly, slightly off camera.
Like Children of the Damned.
I'm pretty sure that like when I look away, it'll look at me, and then when I look at it again, it'll look away. It's one of those sorts of dolls, right? Anyway, so far infrared submillimeter, it really does allow us to see the universe in a completely different way, and it allows us to see things which are really otherwise veiled from view. Now, dust, my favorite thing. Is something that we can very readily study in the far infrared submillimeter. And dust makes up a very tiny proportion of the interstellar medium. So that is the stuff between the stars, the gas, the dust, from which more stars and planets are born. By mass, dust is about 1% of the interstellar medium for like a typical galaxy in the nearby universe.
I thought it was more than that. I thought it was a lot more than that.
Absolutely tiny, tiny. And despite it being such a small amount, it really does have a profound effect on our ability to sort of study the universe. So dust absorbs starlight and then it re-emits it in the far infrared. And it's been estimated that about half the starlight ever emitted across the history of the universe has been absorbed by dust and then re-radiated in the far infrared. So think about that. Half of all the starlight that has ever been emitted has been blocked out, absorbed by dust. So by not looking at the universe in the far infrared, we are literally missing out on half of it. So it is a really important part of the electromagnetic spectrum. And by staring at the birthplace of stars in the far infrared, we can kind of pull back that dusty veil that's shielding them from view. The stars are born in these big clouds of gas and dust, and we can kind of peer through that. And we can see what's going on underneath. So we can see brand new stars that have just ignited. They're heating up the dust around them. We can see the faint glow of debris disks around young stars, which I'm trying to do some serious.
Paul.
I know I'm trying to do some very serious educating here, and Teresa, which is what I've decided to name the doll, has just moved significantly closer to the camera and is making me feel very uncomfortable. So I think the hint might be to wrap it up soon, because the more I talk about dust, the closer she's going to get.
It's like that episode of Doctor Who, Blink, isn't it? The more you talk about dust, the closer the death doll gets.
Yeah, it is. So, I mean, it's a good job that I still have a lot to go, isn't it? So, shall we carry on? So we can look at debris disks around stars, which are ready to form planets. We can study dying stars and, watch these dust factories at work. We can look at stars like Betelgeuse, which has a huge shells of cool dust around it, and we can see all these different shells. We can look at supernovae remnants and watch them literally forming dust. And also light in the far infrared allows us to see some of the oldest galaxies in the universe, which are just shrouded by so much dust because they're just so kind of prolific at producing stars that there's just so much dust. You cannot see them in the optical. Like, you just can't. You look at that patch of sky in optical wavelengths and there's like diddly squat, blank sky. You look at it in the far infrared and suddenly you've got all these glowing blobs. And I think it's just amazing. And so really studying dust is a bit like doing galactic archaeology, because dust is produced by stars. It allows us to sort of trace the past star formation history of a galaxy, and it allows us to figure out what stars were there before and sort of what stages the galaxy has gone through in its history and things like that. So where does my work come into this? So in my first paper, which is on Munras, if you type my name, it will come up and it's super exciting. So I use the emission from dust to trace the amount of gas in galaxies over much of cosmic history. And we couldn't do this for individual galaxies because far infrared astronomy, unfortunately, it really suffers from poor resolution. So anything really beyond the local group, all the galaxies are looking like blobs. And that's if you can even see them above the noise levels in your image. So a lot of the galaxies that I was studying, we couldn't see them above the noise levels. So what we do is we use statistics and averaging techniques. And so what we do is we study these sort of similar galaxies that are similar by mass and they're at similar points in the universe going back through cosmic time to sort of get average properties and kind of figure out the story there. So we use about 63,000 galaxies covering a 1 square degree patch of sky. And we found that as you go back in time, galaxies have more and more gas until about 2.5 billion years after the Big Bang. And then it's kind of sort of seems to level off, kind of plateau. So the mass of gas in galaxies is constant. But once we get back to that point in cosmic time, we're working with low number statistics, not many galaxies. The assumptions we were making were starting to break down. So we don't know whether it's a real effect or if it's sort of an issue with the way we were doing the analysis. But if it is a real effect, it's quite interesting because it's about 1 billion years before we get the peak of star formation in the history of the universe and the time when galaxies were most ferociously forming stars. So is it a coincidence that we get the most gas in galaxies about 1 billion years before we've got the most stars being formed or not? That is the question, which we can't answer with the current data that we have, but there are some studies and stuff coming online which will enable us to maybe probe that part of cosmic history a bit better and help us figure it out. So either way, I reckon that far infrared astronomy is pretty damn neat. It's a really powerful tool for studying all sorts of hidden phenomena. It's particularly crucial for galaxy evolution. And that's why I think everyone should study dust and not just think it's a nuisance.
Boom, we even got a promo for infrared astronomy at the end.
I know.
Ooh. Well, I did put a shout out for another panelist on here to be a stinger hummer, but we've not had anything yet. So, Paul, it's going to have to be you.
No, we've got something on Twitter.
Oh, have we?
We have.
What's that?
Have. Hang on.
Dead air's a crime, Paul.
No, I'm just.
Whoa!
Nice.
Fantastic. Is that mono or polyphonic? That's polyphonic, isn't it? That's fantastic. Who did that?
That's from the one and only Kevin Morgan. Yeah. Try that again, ready? That's nice. I like that. There we go. Thank you, Kevin. Hello. I believe it's just me. Can everyone hear me? Yeah. Yeah. There we go. Look, so it's just me. Well, it's just me running Awesome Astronomy now. Clearly the other two have died. And we've always agreed that if any of them died, we'd just carry on anyway. So we're just going to carry on. So this is now the my Awesome Astronomy. Right. I shall wait and see what happens. I'm waiting for I'm just going to check what's going on.
Methuselah is with you always.
Oh, Methuselah's with me. Come onto the screen. Join us. I feel lonely. Where's Damien? Show us your face.
I am Awesome Astronomy live.
You are Awesome Astronomy. The talking planet. Look at that. Right. Well, I don't know what it is. It's the Paul and Methuselah show. I don't know what's going on. They suddenly just froze. It was Kevin Morgan's tune was so amazing. They just died.
John, Jenny's, and Ralph's internet have all died simultaneously. I believe they are all on Virgin Media.
So Virgin Media has just gone down.
Yep. There's a recommendation for an ISP for you.
Well, there we go. Well, I shall continue anyway. And funny enough, it's very appropriate that Kevin just did the stinger there, because actually the email, our question for the host this evening was actually from Kevin, funny enough, and it was a carryover from our little thing we did, our Q&A, which we never got round to. And Kevin asks, "Oh, Imperial Lords, we should get him on to talk about this." Kevin, are you there? I don't know if I can get you on. No, I probably can't get you on. So, "Oh, Imperial Lords of Lockdown and Majestic Queen of Dragons, may I, as one of your humble followers, dare to be bold enough to put forward a question for your consideration in thine upcoming broadcast from hallowed ground that is Cydonia." I like this. It's very good. Right, enough of that. How on earth do scientists work out trajectories of putting satellites in orbit around other bodies, or on trajectories that take them past numerous objectives, and how critical are these calculations? I get the principle about accelerating items using gravitational slingshot for objects further out than Earth and needing to use gravity to slow objects down for objects close to the Sun, but how do they do it? Many thanks, and keep up the excellent show and Twitter comments. Well, here we are. So, it's all Newton, baby. It's all about the Newton. And Kepler, a bit of Kepler, but really it's Newtonian mechanics. And the equations, in some sense, are actually pretty simple. This is kind of the mad thing about sort of space science and the science of spacecraft. Is actually a lot of it is the stuff you did at school. It is the stuff you did at school, those sort of Newton equations, taken to their sort of more complex level, but the principles are the same. So the example being satellite orbital speed. Satellite orbital speed is the equation for that is velocity, the orbital speed. Velocity equals the square root of g multiplied by the mass of the central body divided by the orbital radius. If you were following that, so that's the square root of g, and of course g is the universal gravitational constant, which is 6.673 times 10 to the minus 11 newtons per meter squared kilogram squared. And it's multiplied by the mass of the body you're going around, so the mass of the Earth, the mass of Jupiter, whatever it is, divided by the orbital radius, how far out you're going to go. So you can calculate the speed you want to go at, and that will give you your velocity around in orbit. You relate this to the question in sort of equations, of course, for acceleration orbital period, and then it's a matter of playing with the Tsai-Klodsky rocket equation, which is your way of calculating your rocket speed and acceleration in a vehicle losing mass. Because of course, if you think of a rocket taking off, it's getting lighter all the time. So the mass of how that rocket is accelerating, and force equals mass times acceleration, all the rest of it, changes all the time because the mass is changing. So there's a Russian, Tsai-Klodsky, who worked out what's known as the rocket equation. And it's not actually that complicated. It's a bit involved. But combine that with that orbital speed one, which you can also rearrange to work out the orbital radius and things like that, then actually that's it. The mathematics is not that complicated. It gets more complicated the further you go, the kind of what bodies you're going around, and of course you've got the sort of 3, 4, 5, 6 body problems of moons going around Jupiter and things like that, and all their gravitational influences. So it is quite complicated, but fundamentally with all of it, it's still Newtonian physics. So if you send a craft to a particular angle towards a body, it will accelerate at a certain speed, and you can calculate its exit angle in a set of equations that are basically in the Principia from sort of 350 years ago. So that's it. There's Einstein, of course, in terms of gravity, has replaced Newton in the kind of bigger sense, but actually on the day-to-day kind of use of rocketry and spacecraft, it's no different. It's still Isaac Newton. So there we go. That's the answer there. It's just me. Yeah, no problem going. Just thank you. But yeah, it's you can look these up. The rocket equation is really fascinating. Actually, it's a really interesting one because it's. I remember once A-level physics. It was one of the problem I had on when I was doing A-level physics. I did a project on rockets, as I would as a nerdy 18-year-old, and it struck me immediately. Like, hang on a minute, how do I calculate how the rocket takes off? So it was my kind of introduction to quite complex physics was working out the rocket equation, which was a great thing to do when you're 18. It kind of felt like proper physics. It was something really interesting. Okay, well, I'm going to finish the show off because we need to finish off. I don't know if they're going to come back. If Virgin Media has gone down the Swanee, I might as well finish us off. And then if anyone's got any questions. Can you still hear me?
Everybody can still hear you. Except you've got your mute. You've muted your mic.
Can you hear me now?
I can hear you fine.
Good. That's okay. I'm getting this message that says your speaker is not working. Oh God, not me as well. Right. Well, that's all they have. I've got to do a Ralph impression. I don't know how to do a Ralph impression. Anyway, well, that's all we have time for the show. Thank you very much for joining us live and contributing to the show in the way we always hoped we'd be able to interact. Every time we record, we intend reading the most recent thoughts and comments as they come in by email or Twitter, but nothing beats having you around us as we're doing it in real time. And I have to say, I do enjoy this. This is quite good fun. I'll have a little read of the comments now, actually, just to what have we got? What are people saying? Is there anything else interesting? Doing great. Well, thank you. Yeah, nothing else there before we sign off. So, remember to subscribe. Remember to hit the subscribe button. Damien has been beavering away putting our episodes on YouTube. So if you want to catch up on the back catalogue, they're all appearing on YouTube. What season are we at now?
Just uploaded season 8. Season
8 is up there now. So we're getting there. And so subscribe, give us Q&As. I don't know when we're going to do a live one again. Hopefully a bit more successfully without people dropping out of the explanation. So until our exploration show in the middle of the month, it's goodbye from Cydonia Base, where I sit all alone with Damien. The
I'll
end.
always be with you.
Oh, that's good. Well, there we go. Like, I'm just going to press stop on my recorder. So that's our episode recorded there. There we go. No problem. Yeah, it was. I hope you enjoyed that. Apart from our sort of disastrous ending there. I hope everyone enjoyed it, and it's glad the best Martian survived the coal. I like that comment. Stop talking, Paul. I will stop talking. I'm going to end the show now. So goodbye, everybody.